Okay, so we're doing 2.6 today. And this I think should be a review. We are graphing rational functions, or another word that we used when we did our BFF was reciprocal functions, okay? I'm gonna make like a little note section kind of like down here, like on the top of the next page or at the bottom over here. So wherever you wanna make like a little bit of a note section, I'm gonna write down how we find all of our asymptotes and our intercepts so that we can refer back to them. So wherever you feel like you have the most space for you to kind of take some side notes, that's where I'm gonna do it. I'm gonna put mine up here. So today we're doing rational functions, or another word we use for them is reciprocal functions. Does anyone remember what my equation for reciprocal functions is? 1/x, perfect. And then from back from our BFFs, you remember what that looks like? I know exactly what you're talking about. We got little C curves in two of my quadrants. Is it first, second, third, fourth? Where are my little C curves at? 1 and 3. It's okay. That's where the basic BFF graph goes. It's where we generally are. Now, if we flip it for any reason, then it would be in 2 and 4, but generally it's in 1 and 3. Okay. Now, when we do this, there are 4 things that I care about, and then there's a potential 5th thing that we need to keep at the top of our mind, okay? So I'm going to make like kind of 4 little categories, or 5 little categories. 1, 2, 3. Oops, I need to make this a little bit. That's good. 1, 2, 3, 4, 5. I want to mention that 5th one with you guys. I didn't mention it with my other class until later, and we almost forgot about it. So I want to mention it with you guys first. And I'll actually do that first. The kind of the least important thing, the thing that doesn't come up the most often, but we need to be aware of, are holes. I could have holes in my graph if I have a canceled factor. So if I simplify the numerator and I simplify the denominator and there's something that cancels out, that gives me a hole. So I've got a hole at my canceled factors. Let me make that a little bit smaller so we can get canceled factors. That doesn't often happen. So a no hole situation is often common, but we need to be aware that there could be an open circle somewhere on my graph. And that comes from if we simplify out, we have canceled factors, okay? The other 4 are a little bit more common, ones that we see more often. I've got my vertical asymptote, my horizontal asymptote. I'll label it vertical asymptote. I've got a horizontal asymptote. And then we have both intercepts, x-intercepts and y-intercepts. Do any of you think you remember how to find any of those pieces? What's one that you can remember? It's one that maybe you remember how to find. Yeah, Avery.
Isn't one of them like the denominator?
Mm-hmm.
Make it equal to x.
Make it equal to 0, and then we'll solve for x. Yeah, so vertical asymptote, you want to set the denominator equal to 0. And so you'll get an x equals numbers, and that number is not part of my domain, and it is my vertical asymptote. We've got the little dash line as we go up and down the page. Okay. The next one's kind of hard. Do any of you remember anything about the horizontal asymptote? Do you remember what I look at, Nikki?
No.
We look at coefficients only after we've looked at exponents. Good. The horizontal asymptote's the hardest because there are 3 situations that we have to be aware of. Okay. So one is if the exponents are the same on top and bottom. The second option I have is if the exponent is bigger on bottom. And the third situation is if I have an exponent bigger on top. Where the exponent is bigger on bottom. See how there's an x down there? If you don't like the 1 over x, we could do it this way. We could go x over x squared. If that makes it make more sense to you, that's totally fine with me. So either exponents are the same, exponent is bigger on bottom, or exponent is bigger on top. Nikki reminded us of the most common one, the one we see the most often, which is when they're the same. And that's when we look at the coefficients. We make a fraction of the coefficients. So if the exponents are the same, then we look out front. And in this case, it'd be 1 over 1. Sometimes it's 5 over 2. Whatever numbers you see out there, that's what my horizontal asymptote would be. Okay. When the exponent is bigger on the bottom, do you remember what my special case for that is? What would my, it's 0, very good. If it's bigger on bottom, its asymptote is at 0. And then we didn't do a lot of these. I kind of previewed, we looked at this earlier in the year and I was like, we're not going to deal with this yet, but we're going to deal with it later. And then today is later. Do you remember what we do if my exponent on top is bigger? We have to do synthetic division because it's going to be a slant asymptote. So we're going to do synthetic division, and it's because it will be a slant asymptote. And we'll see an example or two of that today. Okay. So those are my asymptotes. The horizontal asymptote is often very easy. There's just 3 special cases. We just have to look at all of them. What about x and y intercepts? Do any of you remember how we find the x or the y intercepts? Nikki, what you got? Good. I already did the denominator 0 for my vertical asymptote. So for my x-intercept, we're going to set the numerator equal to 0. And then I could also interpret your make it 0 as for the y-intercept, we plug 0 in for all my x's. So those are kind of the 4 things that we do. The math here isn't hard, but there's just kind of 4 little math problems we're doing in order to graph all of it. Okay. But those are all the steps. And then all we're going to do today now is start graphing. So I did all this work over here. I'm going to pop up here and I'm going to do these 2 problems. So we're going to look at 1A and B now. Okay. So it says sketch the graph. So I'm going to put my graph up here, I think. And then I'm going to make sure that I've got room to show my horizontal asymptote, my vertical asymptote, my x-intercept, and my y-intercept. Also, I usually do vertical asymptote before horizontal asymptote. I don't know why I have them weirdly switched on here. And I don't care what order you do it in as long as you do it. And then I can also go look at the beginning and see, do I have any holes? That can just be like a thought, do I have them? So first thing is vertical asymptote. What do I do for my vertical asymptote again? Good, set that denominator equal to 0. So here my denominator is x minus 3. So we'll set that equal to 0. So x is going to equal 3. And I can go ahead and graph that right now if I want. Vertical line goes up and down. So I'm going to come over here to 3. I'm going to graph that. All right, horizontal asymptote. That's the funny one where we have to think about all 3 cases. Those are my cases. Look at number 1A. Which one of these is going to apply to 1A? Number 1, good. So they have the same exponent. So what's my horizontal asymptote going to be here? 1, very good. The hard thing about horizontal asymptote is there's not like a lot of work. So it's either right or it's wrong. There's not really a lot for you to do there. Once I find that, I'm going to go graph my asymptote. X-intercept. What do I do again for x-intercept?
Set numerator to 0.
Good, set numerator equal to 0. So I'm going to do x plus 1 equals 0. Minus 1 from both sides, x equals -1.
Do you put that in parentheses?
You are welcome to. I'm okay actually if you just leave it as x equals -1. But if you want to write it as -1, 0, I'm okay with that too. Some teachers teach that so that you make sure that you graph the right point. I know it's an x-intercept, so I'm just going to go to my x-axis and graph -1. Y-intercept. Ooh, sometimes that's the one I forget the most. Y-intercept, plug 0 in for all my x's. Okay, so I'll come back up. My original equation is right there. So I'm going to go 0 plus 1 over 0 minus 3. The zeros essentially don't matter, so I have 1 over negative 3. So y equals negative 1/3. And if you want to write that as an ordered pair, you are welcome to. 0, negative 1/3. And it's somewhere between 0 and negative 1. Okay, now is like the actual sketch part. So I've given us enough that I have a shape for my sketch. I don't have any more other direct points. So I have 2 points down, kind of like in that third quadrant of my box formed by those asymptotes. So I'm just going to connect the lines, and I'm going to get as close to the asymptotes as I can without crossing them. The other C curve is going to go in the like opposite quadrant, essentially. So if I'm in the bottom left, where's my other C curve going to go? Top right. And I don't care where you put that, as long as I see a little C curve up there somewhere. That's the sketchy part of it. It's like, it doesn't have any exact points. As long as I've got a little curve up there, I don't care. All right, and then that's my graph. Did we do this before? Algebra 2, maybe? No? Okay. Well, let's keep going. Let's look at the next one. Same idea. I'm going to set my whole problem up, get my graph up. Oh, on that last one, did we have any holes? I forgot to ask. No, because there's no need to cancel. This one we might look and see if we need to cancel to start. So we'll make sure that we'll check for holes first. Okay, so if I go to simplify this first, the numerator becomes what? X squared minus 1. How does that factor down to? X plus 1, x minus 1. And then the denominator, I kind of need 2 steps for that. Let's first take a 2 out. So I get 2 x squared minus 4, and then we can factor that out. It's plus 2 and x minus 2. Can I cancel anything there? No, it's still good to check. And actually, I like it factored now, so then I don't have to like factor or deal with it later. So if you chose not to, that's okay. And you maybe saw from the beginning, you're like, man, Miss White's gonna make me factor this, and I know that they can't cancel anything. You're welcome to not do that then. I just always like to check, double check. All right. Do you think you remember how to do these without me walking through you, or you want to keep walking together on this? Keep walking? Okay. Vertical asymptote. Let's remind ourselves what vertical asymptote was. Denominator equals 0. So I'm going to set 2, x plus 2, x minus 2 equal to 0. When you divide both sides by 2, that cancels out, and that's just 0. So I still get x plus 2, x minus 2 equals 0. And then I can set each of those equal to 0 on their own. Good. So x equals positive 2 and negative 2. So I've got 2 asymptotes here. So I'm going to go graph both of those. Okay. Horizontal asymptote. We go back and look at the original equation, and we look at the what? Well, first we look at the exponents. They're the same, so then I can look at the coefficients. So I just want to make sure we're always looking at those exponents first, then we can decide that we want the coefficients. And so what would my horizontal asymptote here be? Not 0. 1 over 2. Oh, what? Mm-hmm. So my horizontal asymptote is y equals 1/2. So I'll go graph 1/2. That's just somewhere between 0 and 1. Let's see, somewhere in here. Everybody hanging with me so far? Mm-hmm. All right, let's go x-intercept. X-intercept, we said set numerator equal to 0. Okay, so I'll set x minus 1, x plus 1 equal to 0. And Jessica had 2 asymptotes. I got 2 intercepts, and that's okay. Just go graph at -1 and +1. And then my y-intercept, plug 0 in for all the x's, okay? I like for my y-intercept to go back to my original. I like to not do it in the factored form, because that gets a little bit more confusing. I have to work it out. So I just go 0 squared minus 1 over 2 times 0 squared minus 8. 0 squared is 0, so I get -1 on top. And then 0 squared is also 0, and then times 2 is still 0, so I get a -8 on the bottom. So y equals +1/8. And so that's somewhere between 0 and 1/2, so I'm just going to throw them in there somewhere. The last graph we did had just like 2 lines, 2 asymptotes. When I have like these 3 sections, we're still kind of alternating each time. Since I've got points down here in the bottom, I'm going to go through those points and then get as close to the asymptote as I can. So it kind of looks like a little parabola in the bottom, in that like middle bottom section. And then where are my other 2 C curves going to go? Good, top left and top right. So up here somewhere, and up here somewhere. Always. Think about just always going like opposite of where it was, kind of like checkerboard pattern. So like we have this down here, we got to fill in the other 2 parts of the checkerboard. All right, I want you to flip your paper over, and we're actually going to skip 2 and 3 today because that's limit notation. It's kind of weird. We're going to jump over to 4, 5, 6, and 7. Those are really the only other ones I want to do today. Okay. So if you can keep referring back to these things that we made before, you're welcome to. If not, I'm going to copy mine and bring mine to the next page with us. That's some of my notability magic. That might be too small, but that's going to be a later problem. Okay. Now, before we get started on this one, I kind of did A period a little bit, or alpha a little bit wrong on this one, so I've got to do you guys right. Let's see if we can simplify this. Let's look for wholes first here, okay? So when we go to simplify this, what's my numerator going to be on number 4? 3. Good, x plus 3, x minus 3. And then what about the denominator? How do I simplify that out?
3.
3 times x plus 3.
Cancel.
Good, and now we can cancel. I have a canceled term. So I will have a whole at x plus 3 equals 0, which is x equals -3. Now, we haven't done this yet, but when we do cancel, I'm going to tell you for the rest of the problem, we want to use the simplified version. So that's x minus 3 over 3. Which could also be written as 1/3 x minus 1. Is that still a rational function? No. That's no longer an x in the denominator. The canceled term actually got rid of the denominator. And so now I can just graph this. And what shape will this be?
Oh.
A line. It'll just be a line. How do I know it's just a line?
There's no exponent.
There's no exponent. Yeah, there's no nothing. It's just an x. It's just a normal x. So I'm going to graph this like I would graph a line back in Algebra 1. I'm going to go to -1 as my y-intercept. I'm going to go up 1 over 3. 1 over 3. I can also go down 1 and to the left 3. That would get me at -3, and so I'm going to put an open circle there. let's say you forgot your open circle for whatever reason, you could draw your line however you want to do it. It looks nice and pretty. Then just at the end, either erase or just make that spot that you know there should be an open circle, just trace an open circle over that and just make that look intentional. Okay. Since this turned out being a line, I did not have to do, there's no need to find VA, HA. They have X and Y intercepts, but you don't need to find those. We know how to graph a line as is. So we just were able to kind of simplify this down and do the easy way out and just get a line. Yeah, Joey.
When you go from x minus 3 over 3 to get to x out.
Good. I divided each one by 3. So x divided by 3 is the same thing as 1/3 x. And then negative 3 divided by 3 is negative. All right, the next few are more are actually the real deal, so we'll go to those next. Okay. Like we did before, let's still simplify this. Let's see if there are any holes, and then we'll go on. Okay. I think you can do this one mostly by yourself. I'm trying to think of if there's any confusing things besides the simplified. So I'm just going to do my work here, and I'm going to be quiet. So you guys try and do it yourself, and if you get lost, come to the board and see what I'm doing. I'll go graph my stuff in a second, but I've got all my work worked out. Let's do that. I'm gonna do it. Oh no, I already did attendance. Anybody questions on any of those pieces? You have them, see if you can transfer them over to the graph, put your asymptotes up, do your intercepts, see what your curves are. Avery?
So if 5 had an X next to it, it would be another here, it would be another X.
But since it doesn't,
Will it ever?
it could, yeah. Definitely something to be aware of.
But you do include it when you're finding the X intercept, because you have to like.
So I just worried about this when I found the X intercept.
Oh. Oh, it is 5.
Yeah. Back these ones. I really did my color coordinating and then I stopped. I'm so sorry for getting busy. Now, we're lucky we've got points on both of kind of the quadrants we need to be in. So you've got enough information to kind of continue off your C curve. Make sure you just go through the points that you have labeled. Maggie?
Why is the whole not on?
It's not on -1 because technically that's not the actual point it goes through. I was literally just kind of playing in my head, like, do I bring this up or do I not? Some teachers teach you to plug this -1 into the simplified version to know exactly where that hole is. So like you could do -1 minus 5 over 5 times -1 minus 1. So that gets me -6 over 5 times -2, which is -10. And so that would simplify down to what? 3/5. So the actual hole is at -1 3/5. And so that's how I know that it's above the line. I also know that it needs to just kind of go in line with where my curve was at. So sometimes I just draw my C curve and then I go back and I'd be like, okay, -1 is like where I'm supposed to have the hole. So let's just make sure we've got an open circle there. I have sometimes made students find that and sometimes I haven't. I guess just in this moment I realized I didn't talk to Miss Ludington about how we're going to do that. So I'll talk to her and make sure. If that's something that I'll ask, we'll talk about it next class. Are you doing okay so far? All right, we got 2 more graphs, and now you're going to notice that our horizontal asymptote is not just going to be the coefficients. These last 2 have an exponent bigger on top than on bottom. So that means we've got a slant asymptote, our first slant asymptote, okay? So let's do the same thing that we've done. I'm going to start. Let's see if I can get a hole. Let's see if I can simplify. So I get x plus 4, x plus 1, all over x minus 2. Okay, so boo, no holes. That's okay. Holes, and I'm going to say none. We can find our vertical and our vertical asymptote. We can find our x and y intercepts the exact same way that we did before. So I'm going to do those first, and then we'll come together and do horizontal asymptotes. No, wait, change my scale. So vertical asymptote, x-intercept's pretty self-explanatory. Y-intercept, I told you that I normally go back to the beginning, but I forgot to as I was halfway through this problem. So this is just a way to show that you can just do it from the factored form and it still works. You'll get the same answer either way. Everybody okay with those 3 things? Okay, let's do the new thing, the horizontal asymptote. I see that I've got a bigger exponent on top than I do on bottom, so that means I'm going to do synthetic division. When I do synthetic division, what number am I going to put inside the house? What's the denominator? X minus 2, so we're going to put 2 in. Just like how we did before, you switch the sign. If it's x minus 2, then when I take it out, it becomes a normal 2. And then I'll just put my coefficients 1, 5, 4. If you like log division better for whatever reason, you can always do log division. I'm not here to like make things hard for you. I just think synthetic division is easier, so I'm going to keep doing that. So I've got 1 times 2 is 7 is 14, which is 18. What is 18? Remainder. It does not matter. Also, it should not be 0, or else I should have been able to cancel something out. If it was to go in evenly, then those would have had common factors that I could have canceled. So I expect a remainder. I'm okay with that, but it doesn't matter. The first two numbers do matter, and that's now an equation of a line. Y equals x plus 7. When we were doing our polynomial division and we do our log division, remember we are always one exponent smaller than what we started with. So I started with x squared, now I'm down to x. This line is that slant asymptote. So I'm going to go graph this line, and we're going to make that, instead of a horizontal, it's going to be slanted. Does that make sense? Mm-hmm. Now I started graphing my other asymptote, and then I realized I wanted to change my scale a little bit. I'm just going to add a few more dashes so that I can make sure that I can see everything and it's just all on my graph. If not, I'm past 7. 1, 2, 3, 4, 5. 7 would be up here, and that's like in my problem. I don't really want to deal with that. So we're going to go like this. So I'm going to graph my asymptotes. Here's my x asymptote at 2. My horizontal asymptote, remember we're graphing the line y equals x plus 7. So I'm going to go up to 7. 1, 2, 3, 4, 5, 6, 7. And then I'm going to go up 1 over 1, up 1 over 1. I can go down 1 over 1, down 1 over 1, something like that. And so that little dashed line, beep, 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 beep. Notice how mine like isn't perfect. I don't expect yours to be perfect either. But I should do something like this. Now I'm going to do my asymptotes, -4, -1 on my x-axis. And then my y-intercept is at -2. And then now I'm just going to connect my points, try and get as close to the asymptote as I can. This one's kind of funny down here. It looks like something like that. As long as you don't cross an asymptote or don't cross an axis unless you have a point. If this is where one of my C curves is my other one in this part, the second part, or this third part? The little tiny 2 part. And again, I don't really care as long as I see a little C curve up there somewhere. Little C curve up there somewhere. Okay. I got one more problem I want to do with you. I think 7's that last one. And then we skipped the limit notation. That's easy. We could have done it today, but I knew with a lot of people missing, and I'm actually okay slowing this unit down a little bit. We're not going to do that. Do you think you can try to start this without me? Okay, try it. Try it without me. If you need to check in, I'll be on the board. I got all my pieces up there. So wherever you're at, make sure that you're doing okay, and then I'll transfer it over to the graph in a second.
So we just graph from 0.
So the graph of y equals x is just 0 intercept. Go to 0, the origin, and then up 1 over 1, up 1 over 1, up 1 over 1. Joe?
On number 4, did we just know that that wasn't a slant because we knew it?
Number 4, we knew wasn't the slant because when I simplified out, I got down to a line. On the other two, we tried to simplify, like this one, we tried to simplify and we couldn't. So it stayed with the exponent bigger on top. That's a good question. Okay, I'm gonna start transferring this over to my graph. I got my asymptotes up. I've got my intercepts up. I don't have any holes. Now we have points in kind of the 2 quadrants that we need them to be in. So we're just going to make a C curve over here. We're going to make a C curve over here. So I'm just going to try and like get as close to the asymptotes as I can. Go through my points, hit the asymptotes again. Get as close to the asymptote as I can, hit my point, get close to the asymptote again. Okay. We doing all right? Okay. That's all I got for today.